Hello and welcome to another video. Today we have a board of a viewer. We have a letter right here. Let's see. Let's get some focus onto here. Hi, this Gigabyte TRX40 board is from a Chinese reseller that I needed a replacement board for a build. A board secondhand on marketplace. A few days ago, the new board still worked. Both the board and RAM had RGB lights, and I was able to get post and was excited to start my setup. However, a few days later I cannot get post anymore. Right now it seems the DRAM light is burning red. One of the lights was burning when I was working when it was working as well, but I considered it a bug or a quirk. I did not spend time to investigate this since the system booted instantly with this new board, so I did not anticipate further issues with it. Okay, so we have this Threadripper board, I think this is. These are quite beefy. Like if you remember the X99 sockets from Intel, these are basically like workstation consumer. I think these are considered workstation ones, but still consumer grade. And yeah, it seems to be that we have DDR issues with connecting, and that could be multiple things. That could actually be a problem with data lines. But that, as he described, that the board was working fine before and then all of a sudden had an issue. That could also mean that this one has problems with its BIOS. So normally, as far as I know, you would need an actual, a specific driver to torque this socket down. But let's see, to open it up, you need to start from 3221. It specifically states that on the socket itself, in which order you should do it. So let's see if we can successfully plug a CPU into this socket right here, because it's not as trivial as on other boards. So this is removed, and let's first have a look at the socket against the sun. And as you can see by the reflection of the pins, you can quite easily see if there's anything that is like misaligned or something, but it looks very clean. So he provided a CPU for this. It should work, the CPU, but I cannot confirm it yet. So we have this CPU here, and I can already see that the CPU, as you can see, is a little bit dirty there at the corner. So I definitely want to clean that off before we will try to get this into the socket. I gotta be honest, I have no flippin' idea how this thing goes into the socket. It has something to do with these rails, and I will have to look up how exactly that is done. Because yeah, I get to work with sockets like these very rarely. I think I had it once before where I worked with a socket like this. And yeah, every time anew I have to look up how to properly set these, because not properly setting these in can also lead to issues with recognizing RAM. I kid you not, it took almost 30 minutes for me to install the CPU. Thank God there was this covering frame, because the big struggle that I had, the carrier frame for the CPU that holds it, the orange one, has its latches kinda broken. So it didn't hold the CPU in quite right when you were fiddling it into the carrier frame to then put it down. I had to try multiple times to realign everything and clean off the bottom of the CPU, just in order to be very sure that the socket sits firmly. But now I think the CPU is installed right. So what I want to do, I want to confirm the fault first. So we're going to go with DDR4 right here. As far as I know, plain old DDR4 is fine for this socket. And pretty surely it has to be this one first that you have to start. Because there are sayings, there are some markers right here. It says A1, A2, B1, B2. And it says you need to populate A2 and B2 first. And then on the left side, there's D2, D1, C2, C1. So the left ones are to be populated later, first these ones, and you need to start with A1, A2, and B2. So we're going to start with that. So let's see. This thing does not have a power button on its own. So we will need a power button, and we probably put a speaker onto here as well. So power button and speaker installed. Let's now see for the 24-pin connector and also the 12-pin EPS. Let's get a cooler onto here. We're first going to start with this cooler. We're not going to stress the CPU, so there shouldn't be a problem with getting this partial cooler onto here. So let's see for its power consumption. We do expect that this has a reaction to the power button. So 300 milliamps. That is kinda a lot, but I don't have any experience with these boards if that is normal or not. Okay, let's hit the power button. Do we have diagnostic LEDs anywhere? Yeah, we have at the bottom right, we have diagnostic LEDs. Let's then go down there with the camera, just in order to see if we actually get stuck on a DRAM LED. It starts top left CPU, top right RAM, bottom left VGA, bottom right boot. Okay, let's hit it. Okay, CPU, DRAM. Back to CPU. 2.5 amps. At the beginning I saw 6 amps of power consumption. And now it seems to be stuck on a CPU LED. We might have a problem again that this takes too much power for my power supply, because now it's definitely stuck. Let's hit that again. So pressing the power button to turn it off, it won't turn off by itself, I think. No, doesn't react to the power button to turn it off. Then let's power cycle it, turning it on again. 300 milliamps, and let's hit that again. You can see 6 amps DRAM, and this time we're stuck on a DRAM LED with 2.5 amps. Okay, just to be sure, I want to get a 24-pin of a normal ATX power supply in here, just to confirm that it's doing the same thing then, that it's not my power supply holding us up here. So the power supply is attached. Let's look in the bottom right again, and let's see now. Reaction to the power button, DRAM, CPU. And it seems to behave the very same way. And just CPU stuck. Okay, so it isn't the problem with my power supply, that is the actual state of the board currently. Okay, let's then get my power supply back onto here, so that we can see power consumption and see if there's any change for this board at any point. So first things first, we're going to pop the battery on this thing. We have a CMOS battery right here. So let's pop the battery out. Let's see, do we have a clear CMOS header pin button on the back? We do not. We only have a Q flash button. Okay, let's see. Clear CMOS header. Yeah, the right one. We have a clear CMOS header right at the bottom there. So I'm just going to take a screwdriver. We're just going to short these 2 pins. And after having those 2 pins shorted, let's see this again. So power consumption, 330 milliamps again. And let's see, hitting the power button. And same behavior. We get 2.5 amps. Okay, this actually seems like it could be a stuck BIOS or a problem with the BIOS in itself. He did say that he tried the Q flash button, but that didn't work out for him. So let's just try with a different position for the memory, just to be sure. So now with the memory in slot B2 instead of A2, let's see this again. And the behavior seems very similar. Yep, same thing. Let's now try it once more, just to try it also in D2 and in C2. Even though you shouldn't probably populate those when the other side isn't populated yet. So this definitely seems like a BIOS issue to me. And I have seen the dual BIOSes of Gigabyte fail very, very often. This has the typical main BIOS, backup BIOS thing, of Gigabyte, and I have seen it fail over and over again. I want to try one more thing. I want to see if it complains about RAM when we don't put RAM into here. So if you start without RAM, we get stuck at that. Oh, okay. It behaves very similarly. That it complains about RAM, but I don't get beeps on my speaker. So what I want to do, let's see for the data line tester if we have anything knocked off. So let's get the data line tester into here and make a check. And having a look at our data lines, I cannot see a single one missing that should be there. So the data lines itself is definitely not the problem. One more thing that we can check is there are VREF circuits for the VRAM, for the DRAM, and you can check those in diode mode. So you probe one probe on ground and then check the VREF pin on this tester, and you want to see that you get an actual diode reading, like right now, that it isn't 0. Then there's also a SPD reading. That might be interesting. That shows open line, that SPD. No, it doesn't. But that SPD reading shows 0. Interesting. Then we have a select. We have an SCL and SCK for data and clock. And that seems fine. But that SPD reading was quite interesting. I think we just saw a short circuit on the SPD line. Let's get the DDR4 voltage line tester into here in order to see if we get all of the necessary voltages for DDR4 then. So this might after all be an actual DDR problem and not like a BIOS problem. Let's see. For that we need to switch the board on. And let's see here now. So we seem to get all of the voltages except RCA. There seems to be no connection with RCA. Oh yeah, now there is. Okay, this was it's just the DIMM being a little bit fiddly in here. So we do have all of the voltages. The SPD also shows 2.5 volts. So that should be fine. Yeah, right there, checking once more on another slot, all of the voltages are definitely there. So yeah, for the BIOS, for the actual RAM, we have checked most of things now. We have data line connection. We have all of the voltages, and the VREF seems also be fine. So with my experience, knowing how this main BIOS and backup BIOS behaves, I would want to go into taking out that main BIOS chip in order to verify its content. And then what we can also do, we can take out that main BIOS chip and just try the backup BIOS if that already works or not. So this board doesn't have anything where we could attach to. No SPI headers. So we will have to hot air this off. I can see this is an MXIC chip 12873F. I think this is 1.8 volt chip with 128 megabytes of memory. So let's then do the usual way of how we do it. We're going to apply some leaded solder to it. First we get some flux into here. And let's now put some leaded solder on each and every joint. This is very close to the DDR sockets and to the plastic of it. So I will be covering that up. I will just get some insulation tape so that even if I touch them with my soldering iron, they don't get burned. So I have my adapter board ready to put that chip onto there. So let's take our hot air station and let's blast that chip off of there, and I'm instantly going to put it also onto the adapter board. So chip is off, and now I'm putting the chip onto my adapter board. So we got the chip now sitting on our adapter board, mining pin 1 at the top left. Chip looks fine. But before we now going to try to look at that chip. Let's clean up the area a little bit so that our flux doesn't go hard here. So our area is nice and clean, nothing is shorting. And I want to know now, if we now try to start this board up, if the backup BIOS might get triggered now and is actually getting us to boot into the board. So let's see. So I'm very curious if that can already have solved our problem here. So let's get passive power consumption into here, 330 milliamps, and let's hit the power button. And we get the very same behavior. So it didn't change at all. It still went to 5, then 6 amps, and then goes to 2.5 amps again. This time stuck on a CPU LED. Probably if we cycle it once more, we probably get onto DRAM LED. So no change with having the backup BIOS in place now. We get the very same behavior. 5 amps, 6 amps after the initialization of the CPU. We get to DRAM 2.5 amps, nothing. Okay, let's then get to the programmer and see for the content of the main BIOS chip. So let's now identify the chip. It should be a MXIC 1.8 volts. There it is. And let's read out the chip now. So we don't know what could have happened to this BIOS, and also because he tried to use the flashback function, who knows whatever happened to it. And in addition, we have the Gigabyte dual BIOS, and who knows how that influenced the chip. So we got content, and it looks fine, to be honest. Like, we definitely got this read out. I'm going to save this original BIOS from here now. So I went ahead and downloaded a BIOS off of the actual Gigabyte site, and we can see it has the same size as the one that we got from the dump. So we're going to open up that file now, and it looks very similar. Like, I cannot see big differences now. So let's program that. Yeah, so let's program this BIOS and hope that this will now fix our issue. So the programming is basically done. Let's see now if the chip also can get verified. This is basically the most important step of seeing if the flash chip is okay or the EEPROM is okay. And it seems to be fine because the verification goes on. I've seen this fail in a progress, but yeah, it looks very good. So after this verification, let's get that main BIOS chip back onto the board and see how it behaves. So let's apply some fresh flux now onto here. I have masked off the DDR sockets again, so that they are protected. And now let's hot air this back on. So first needing to take it off of my adapter, and then placing it onto the board with the orientation to the bottom right. So chip is back on the board. And now let's get some more flux into there and clean up the solder joints. So all of the connections are well established. Let's get some cleaning into here again so that it looks nice and fresh here. So let's get back onto the overview and see. So we got the main BIOS flashed. Let's see now if we now can get anywhere with this board. So let's have a good look at the power consumption also. And let's hit the power button. No, same behavior. That is very bad. 2.5 amps and stuck. So because I'm curious, I'm going to take off this backup BIOS and I will also flash it. And before flashing it, after I've taken it off, I want to try to switch on the board just to make sure that it definitely uses the main BIOS here. So same procedure as before. So backup chip is off now, only the main chip that we have flashed. Let's see now. 330 milliamps of power consumption, and let's hit that button. And very same behavior. So it really does not seem to be a BIOS related issue here. just in case I'm going to swap over to, my normal ATX 24 pin power supply in order to check that the behavior is also the same on that one. So while I was looking around, because I didn't know where to continue, I actually found some missing components. This is the backside of the board, and this is the V-core circuit. As you can see, there's always like 2 resistors in pairs with 2 capacitors, and we seem to be missing these 2 resistors right here. And the question is, did anything else get whacked as well? Because I don't really know how, like, these might be, you know what could be the problem here? Okay, I have no idea what these are for, but these might be for V-in sensing. So this might be completely BS that I'm talking right here, but if I would have to guess from the limited experience that I have, there are V-in circuits or V-sense circuits from the PWM controller back, from the V-core back to the PWM controller to basically being able to monitor every single phase. And it might happen that as soon as we try to start, it starts because V-core partially starts, but part of the V-in sensing gets an error, and that's why we get stuck. That's why the board shuts down by itself or gets stuck in this loop. This might be true, but it might also be that we put these 2 back and nothing changes. Because we do know that many boards do start with missing V-core phases. I have done that before, where I didn't have the fitting MOSFET or anything, and I just left out the phase completely and the board was fine. So this might be totally crap, what I told here, but we're going to find out that that might be the case. So let's prepare this. So we're going to put leaded solder on there so we can easily put back the resistors there. So the place is prepared. Let's have a look in the board view what kind of resistors we need. So back in the board view, we have these ones. Power good out. Okay. Yeah, we have V-core on one side. And where does this travel? Yeah, this travels to one of the RMOSes. That 0 ohm resistor. So that can be just bridged, because this is just a 0 ohm. And then it goes into a 1 ohm resistor from VCC. What exactly is VCC supposed to be? Is this 5 volts? This might be 5 volts. So this might be the 5 volts for a DRMOS to work. Yeah, these are 2 completely different things. So what is happening is that this DRMOS here isn't getting its VCC. So there's a 1 ohm resistor that's providing 5 volts to that DRMOS. Okay? And the other component that we have, this 0 ohm, is V-core also back to the MOSFET. So probably a feedback or something like that. So these 2 are actually not related to each other, these 2 resistors, just that they both go to the RMOS. So we need a 1 ohm and a 0 ohm resistor, which is basically twice a 0 ohm resistor. So when we're now back onto the board and we compare to the other phase right here, to the next one right next to it, we see, oh, the multimeter isn't active. So let's see right here. In the neighboring phase, when we try these resistors, this one is basically 0. And this one measures a little bit more like 2 ohms. Which is what 1 ohm is basically also 0. I will have a look if I have something that is similar to 1 ohm, maybe 2 ohms or something like that, but I think we're just going to bridge both of them. So let's make it so it looks better. Actually get 2 resistors in here instead of just botching in solder joints. Let's get 2 resistors into here, so that some people can sleep easier. So both resistors are there, and what I always like to do is to reflow them with hot air. So both resistors are reflowed, both are in place. Let's quickly clean up the area. So our area is cleaned up, and if we now take our multimeter, let's do some measurements. Measure here, basically 0 ohms. And here, a little bit closer, yeah, also, but also basically 0. But that should be fine. Let's now go into the overview and see if this has made any change for us here. So I'm very interested now if this will have any effect on our board now. If this can get us to actually boot up, or if this was just additional damage that has occurred. So let's watch closely the power consumption that we have. And let's see now. Turning on. 5 amps, DRAM LED. This looks very good. 6.3 amps, DRAM LED still. We don't have the same behavior as before. There's a boot LED, a VGA LED. That is very good. Do we get complaints about VGA? Oh, okay. That drew a lot of current. Holy moly. If you saw that, that drew like 20 amps. I hope my tester survived that. Because, yeah, this is a very high-end CPU, I guess. With a Threadripper 3960X. Yeah, my tester is not made for that. Like, my tester is already made for a lot of current. Like, this thing is made for up to 15 amps. But 20 amps is way too much. Like, because we had such short bursts of it, I think it was fine. It might be dead already, to be perfectly honest. But we have good and bad. Because the bad... Okay, the bad is the board. I might have blown up my tester, but the good is I think the board is working now. Let's get an actual ATX power supply then attached to here. And let's get a boot screen out of this. I need to put a GPU into here. Man, I hope I didn't blow up my tester. I will have to test that on another board that doesn't draw 20 amps. So, okay, with now a GPU in here, let's see if this board now boots up. So, let's see. We have a DRAM LED. And we should go to VGA next, because now we're not cycling anymore also. There's the VGA LED. Let's see, do I have my post screen enabled? Post screen is enabled, so we should be able to see it every second now. We are... Okay, it cycled again. We are back to DRAM. VGA. And again a cycle. It probably doesn't like the GPU. UEFI BIOSes don't like this GPU. VGA. And there it is. There is the Aorus logo for this. Very, very good to see. Oh, it's updating some kind of firmware. I cannot read that. I need to enable my own screen that I use for post in order to do not turn off system, do not reset system. Please wait for BIOS to update. Okay. We won't touch it. Just let it update. Man, I really hope I didn't blow up my tester. Like, so many things are made for so much less amperage. Like, with 15 amps that I have configured on my board, on my tester, I basically am over every single limit that everyone else ever used for anything. Like, 15 amps should be plentiful, but yeah, I guess I did not account for workstation boards that have like high-end CPUs. Like I'm not too sure what this is. I think this is a 64 core processor right here. And yeah, which is like pretty beefy. A 24 core processor, okay, yeah. And the CPU temperature is quite high, but we got a boot out of this. I'm so happy. Let's see that it boots up and down correctly. So let's try that one more time. Let's see if it boots now faster than before. Yep, it booted faster this time. So, because I don't want to assemble the cooler and everything onto here, because I'm pretty sure it's fixed, we're going to leave it at that. Because, yeah, the board is pretty certainly fixed, and it was caused by physical damage. So, the big part here was that the owner told me that all of this started after he had tried to put this into a case. And this explains it very well, how that damage occurred. And which is what is even more interesting now, that we got fooled by a DRAM LED that actually was no DRAM LED. Because it seemed to have gone through a self-check for the CPU. It has passed it for a short time. And after that, it went to DRAM, but in that time, the CPU actually threw a fault condition because one of the power phases wasn't running and then stopped there. That's like the way the power consumption worked. We should have known that, because in the power consumption before we saw 5 amps, 6 amp and then 2.5 amps flat. And that should have told me that that's like a protection feature for something happening. And yeah, like that, a CPU LED got disguised as a DRAM LED and fooled me into searching for a DRAM fault that actually wasn't there. So yeah, that it can happen. I still have to put back the secondary BIOS chip that isn't on there. And what I will do, I will get a dump of that EC chip. There's EC firmware on here that you cannot download, and if you have a known good working board, these are so valuable to get the EC dump out of. If you've seen one of my latest Gigabyte videos where the EC dump was faulty, that had enabled me to get like PCIe working again and similar stuff. Like this firmware in here is really valuable. So I'm going to pull it off of here, going to save it to my stash, and going to put it back onto here. But the board is fixed, and that is the most important thing, because this is a very expensive platform, and the person was quite frustrated in the way that this has happened to them with this board, because they had a bad socket first on one board and then got this as a replacement, and they were quite upset when it happened that this board all of a sudden didn't work as well after he tried to put it into a case. So yeah, I hope you learned something. I hope you enjoyed this video. All of my tools, as always, are linked in the video description if you want to get one of these testers for you as well for the power. Email me. I have that link in my video description. And yeah, you can also get that software with it. Don't worry. So thank you very much for watching. This was Mainboard Medic. Thank you very much, and goodbye.